Infinite loops. We've iterated through lists that have a discrete beginning. Notice the spelling of discrete. You can imagine the T in the word acting as a single sort of boundary between the E's on this side and the E on this side. So symmetrical, one E on each side. And that's what discrete means, really. It's about separating things so that they're isolated in their own containers. We don't get that kind of pattern if you spell it E-E-T, because that's a different word. So we've iterated through lists that have a discrete beginning and end, meaning sort of a distinct beginning and end. However, let's consider this example. So my favourite numbers, and we're using the American spelling for favour, because they are the dominant empire when it comes to information technology. And we've assigned to it this list 4, 8, 15, 16, 42, so 5 elements. And we've got a for in loop. For number, that's our temporary variable. For number in my favourite numbers dot append, and we've fed in 1 as the argument to the append. So presumably we're adding on 1. Take some time to ponder what happens with this code. Click to see what would happen. Well, hold on. Right. Well, no. Okay, yeah, sorry, unclick. Let's think. So, I think it's just going to add 1 until infinity. Yep. So here's what happens. Every time we enter the loop, we add a 1 to the end of the list that we're iterating through. As a result, we never make it to the end of the list. It keeps growing forever. A loop that never terminates is called an infinite loop. These are very dangerous for our code, because they will make our program run forever, and thus consume all of your computer's resources. A program that hits an infinite loop often becomes completely unusable. The best course of action is to avoid writing an infinite loop. Note, if you accidentally stumble into an infinite loop while developing on your own machine, you can end the loop by using Ctrl and C to terminate the program. If you're writing code in our online editor, you'll need to refresh the page to get out of an infinite loop. But usually it's Ctrl C. Let's fix an infinite loop to see it in action. Suppose we have two lists of students. Students period A and students period B. We want to combine all students into students period B. In your code editor, we have provided you a loop. Go ahead and uncomment line 5. And before you run the code, ponder why this code would cause an infinite loop. So let's take a look. So we have students period A, Alex, Brianna, Sherry and Danielle, or Cherry, and students period B, Dora, Minerva, Alexa and Obi. And we have a for in loop for student in students period A, the one with A, B, C, D, the names. Well, we can uncomment this line by doing Ctrl// and you can see that it says .append student. So we're going to repeatedly append an element to the list. So Ctrl// and then if I click run, I think that's just this. There we go, and it says lost connection to Codecademy. We get the loop running here, and it keeps running, Yeah, it just keeps running, okay? So if we comment the line back, Ctrl//, we're not going to get our button back, so we can't, I can't click the reset workspace button, and I can't click this. If I do Control-Enter again, no, I've lost control, so I'm going to have to refresh the web page. So there's an infinite loop. We're appending, and you can see it's not that shocking. You can imagine yourself doing that. You might think, well, for all the students, no, for the list, maybe you want to add something to each element. That's not how that method works, but maybe you'd think that. Or maybe you do just think, okay, we need to add something on here. And so you say for student in students period A, and you and think that you'll just have it added on. So a loop that never terminates is called an infinite loop. We've read that. Instructions. Suppose we have two lists of students. In your code editor, we have provided you a loop. Go ahead and uncomment line 5, and before you run the code, ponder why this code would cause an infinite loop. Well, we've done that. When you are ready, run this code. What do you notice happens? Over the run button, notice the loading circle is continuing without anything happening. This is an infinite loop. To end this program, we must refresh the page. Note, the reason this loop is infinite is that we're adding each student in students period A to students period A, which would create a never-ending list of all the student names. Ah yes, so we're feeding into .append student, which is the temporary variable we've set up. And it says open this after you refresh the page. Delete the line causing the infinite loop and fix it to accomplish the original goal of combining all students from students period A into students period B. Okay, so how do we fix this? Let's keep the hash. When it says fix it, do you mean fix the line or just the loop? If you're saying fix just the line, then I'm not sure that's possible, because whatever we do, it's for student in student period A, and that this temporary variable is always going to represent the individual element, isn't it? In the collection, that's how it works. And if we want to add this list to this list, that's our goal. We don't really want to do anything with each element. You know, I don't want to add the list to that element and add the list to that element and add the list to that element. Oh no, okay, so I suppose what we could do is iterate through each of these elements and say, okay, you will be added to students period B, and you will be added to period B. Okay, I see. And we could use student for that. So for student in student period A, do we just do student period B dot append student? We're just going to take student period B dot append student, but then we'll still be adding on forever. I can only think of how to do it using a while loop, so we could do a while loop. I don't think that's it. Okay, that's it. I don't understand that. Why is that not going on for infinity then? I mean, structurally, this seems to be the same as this example. So why is it that this example is problematic and this one is not? As far as I can tell, we will be going round the members in students period A for infinity. Is that right? So why does it not cause an infinite loop? Why does it not cause an infinite loop? The code does not cause an infinite loop because it appends each student from students period A to students period B, not back to students period A. The loop iterates over students period A, which has a fixed size, and does not modify it during iteration. Therefore, the loop completes after processing all elements in students period A. Yeah, but all of that applies to this example. I could say it append for each number in my favourite numbers, we add a 1 to the end of the list. It iterates over the list. The list has a fixed size, which is what we say here. And it does not modify it during the iteration. But I don't understand. The list is modified. Well, the list students period B is modified, but the loop iterates over students period A, which remains unchanged during the loop. The infinite loop occurs when the list being iterated over is modified in a way that affects the loop's termination condition. Here, students period A is not altered, so the loop completes normally. But no, so my question is why does the fact that students period A remains unchanged mean that there is no infinite loop? Surely we can iterate over the collection until infinity. Well, in this case, the loop iterates over students period A, which has a fixed number of elements. The loop will run once for each element in students period A. And since the list itself is not being modified during the iteration, the loop will eventually reach the end of the list and stop. An infinite loop occurs when the condition for ending the loop is never met. condition for ending the loop is never met. Here, the loop's condition is based on the number of elements in students period A, which does not change. So the loop will terminate after processing all elements. What do you mean, the loop's condition, actually? Because we're not talking about while loops, which do have an explicit condition area. We're saying this is a for in loop. We just say for in. What do you mean, the loop's condition? If students period A were being modified to add more elements during the loop, it could potentially lead to an infinite loop. Well, why doesn't the following code simply end once we have iterated through every element in the collection? Extremely slow. Well, this code results in an infinite loop because it modifies the list during iteration. But that's not my question, is it? I know it modifies the list. Each time the list runs, it appends 1 to the end of the list. This means the list keeps growing and growing, and the loop never reaches the end of the list. I know that. Here's what happens step by step. Start with the list, iterate over each element. For each element, append 1 to the list. This is a strange way of speaking, isn't it? So on behalf of each element, add 1 to the list. We're not adding 1 to each element. We're saying, on your behalf 4, I will add a 1 over here to the right of 42. And on your behalf 8, I will add a 1 to the end of the list, to the right of the one I just added. 3. For each element, append 1 to the list, yeah. 4. The list grows. So the loop never finishes it. Now I understand. The list grows, so the loop never finishes iterating over all the elements. I see. So the list, what we're saying is that what you're saying is the loop doesn't make any distinction between the original members, the original elements, and the one that's it's added. So the loop doesn't go, okay, on your behalf 4, I will add a 1 at the end here. And then it goes, on your behalf 8, I will add it. On your behalf 16, I will add a 1. On your behalf 42, I will add a 1. Now I thought it stopped there, because it's gone through them all. But it doesn't know that it then moves on to the 1, and there's a 1 here. Look at my mouse. And it says, on your behalf 1, I will add a 1 here. So it thinks that this 1 is just another number like these. It thinks that even the elements that the loop was responsible for appending, they are themselves bases or reasons to add more, to append again. So we're saying that the numbers that get appended become the material for the temporary variable. Okay, so it's like a sort of self-feeding engine. We're saying that we append elements and they are the material for running the loop again. Remember, this is a temporary variable between the keyword for and the keyword in, and what it does is it takes the elements take turns being the value of the temporary variable. So first we say number has 4 assigned to it, then we say number has the value 8 assigned to it, so all of the elements take turns. And now obviously each time we assign a value to number, whatever the temporary variable is, we go through and run the action. And we're saying it keeps going. 16 is the value, then 42, and then 1. So 1 gets fed in, and so so that's why it's important that when they say the list gets changed, because that's what got me. Right, this AI learning assistant kept saying, it kept talking about the fact that of whether or not the loop modifies the list, and that's related to whether it's an infinite loop or not. And I kept thinking, well, what does that have to do with it? Because I thought it was just the fact that we just do sometimes go around and around 4, 8, 15, 16, 42, 4, 8, 15, 16, 42, and sometimes we don't. But now I see why it's relevant. It's the fact that you're adding material to the list. They say modify, I like to say add. So if we look at this example, we have students period A, right? Alex, Brianna, Sherry, Danielle, students period B, Dora, Minerva, Alexa, OB. And then we've got this for in loop. So for student, that's our temporary variable, in, and that's the name of our collection. And what we're doing is naming this first list. We're not naming students period B. So for student, in students period A, students period B dot append, and then feed in student. And then print student. So remember, student is the things in student period A, the things in this list. So student is Alex, then student is Brianna, then student is Sherry, then student is Danielle. So for student, in students period B, in students period A, do students period B dot append that. So take turns adding each one of those elements onto students period B, and then print what you've just put on. So print Alex, then print Brianna, then print Sherry after you've added Sherry, then print Danielle after you've appended, then print Danielle. So if I run it, we get each one printed. Okay, question, why is this not an infinite loop? Because there's no material being added to students period A. That's how I'd like to put it. And this gets to the nub of it. The loop seems to have enough, I'm going to say intelligence. The loop seems to have enough intelligence to know that it's already done Alex. Because it goes Alex, Brianna, Sherry, Danielle. And then it stops. Now there's obviously something that means that it's not going back to actually going back and repeating with Alex. Because it could do, couldn't it? It could go Alex, Brianna, Sherry, Danielle. Alex, Brianna, Sherry, Danielle ad infinitum. But it doesn't. So it's got enough intelligence to do that. But it doesn't have enough intelligence to know that if it adds an element and creates a fifth element, it shouldn't treat that as one of the values of the temporary variable, like it does here. And that's why it's confusing, because to me that seems quite arbitrary. It knows to stop after doing that, after going through to the list, but for some reason, if it adds its own elements to the list, it's unable to see that they've just been added, and so it treats them as just as a value for student, and therefore a reason to carry out the action in the body of the loop. So the thing that really makes a for in loop problematically infinite is the fact that it's kind of self-affecting. Because look, here you can't just say that it's the fact that it adds material, because here we're appending. So if that's your only reason for saying that this loop is problematic, it adds material, that won't work, because this adds material. So why is this not an infinite loop then? Because it's adding material to students.b. It's putting it somewhere else. It's dumping it in students.b. And students period B is not the place that the loop goes to get to find its material. So it's outputting something here, material here, but fortunately the collection that we iterate over is students period A. The loops become problematic when the collection that we iterate over is the same collection that we go to add material. Right. So here, the collection that we go to is called My Favourite Numbers, and that's also the collection where we're adding material. And so the collection that we consider is continually getting larger. And every time we consider it, we make it larger. And so we consider it again, and then we make it larger, the thing we consider, and then we make it again. And so obviously our task is never complete. So it's this kind of reflexive notion. It kind of points at itself. The loop sort of points at itself. We've got this here, and that same thing in the action in the body of the loop. Right. Loop control, break. Loops in Python are very versatile. Python provides a set of control statements that we can use to get even more control out of our loops. Let's take a look at a common scenario that we may encounter to see a use case for loop control statements. Take the following list, items on sale, as our example. So we have items on sale: blue shirt, striped socks, knit dress, red headband, and dinosaur onesie. It's often the case that we want to search a list to check if a specific value exists. What does our loop look like if we want to search for the value of knit dress and print out found it if it did exist? What would our loop look like if we want to search for the value of knit dress and print out found it if it did exist? It would look something like this. For item, in items on sale, if item is equal to knit dress, colon, print found it. So there's a condition in the action body. We know this is the comparison operator, it's not the assignment operator. So if item has the value knit dress, colon, and that's where the real action comes. So we've got an if statement inside the for in loop. This code goes through each item in items on sale and checks for a match. This is all fine and dandy, but what's the downside? Once knit dress is found in the list items on sale, we don't need to go through the rest of the items on sale list. Unfortunately, our loop will keep running until we reach the end of the list. Since it's only 5 elements long, iterating through the entire list is not a big deal in this case. But what if items on sale had 1,000 items? What if it had 100,000 items? This would be a huge waste of time for our program. Thankfully, you can stop iteration from inside the loop by using break loop control statement. When the program hits a break statement, it immediately terminates a loop. For example, take a look at this code. So you can see that after the line where we say if item is equal to, that comparison operator, if item is equal to knit dress, colon, break, and that's a keyword, break, and then print end of search. This would produce the output, checking the sale list, blue shirt, which is, okay, so that's printed, print checking the sale list, blue shirt, striped socks, knit dress, end of search, which is from the print statement there, end of search. So here we have the if statement, then the colon, which is like, take this action and print. Here we have the if statement, then the colon, and then just break. So the action is different, right? Here we said print found it, and that's indented below the if line, so it's indented below the if line, the print statement. Here we're printing end of search rather than found it. I'm not sure if that matters, but the print statement is kind of is not at the same level, is not within the if statement. It's not kind of a consequence of the if statement being satisfied. When the loop entered the if statement and saw the break, it immediately ended the loop. We didn't need to check the elements of red headband or dinosaur onesie at all. Now let's break some loops. Instructions. You have a list of dog breeds you can adopt. Dog breeds available for adoption. That's the name of the list. Dog breeds available for adoption. You can already see we've got a list here. A French Bulldog, a Dalmatian, a Shih Tzu, a Poodle, and a Collie. Using a for loop, iterate through the dog breeds available for adoption list and print out each dog breed. Using the temporary variable name of dog breed, use the temporary variable name of dog breed in your loop declaration. Right, so iterate through the dog breeds available for adoption list and print out each dog breed. So for dog breed in dog breeds available for adoption, print dog breed. As it says, using a for loop, iterate through the list and print out each dog breed. Okay. 2. Inside your loop, after you print each dog breed, check if the current element inside dog breed is equal to dog breed I want. If so, print they have the dog I want. So inside your for loop, after you print each dog breed, check if the current element inside dog breed is equal to dog breed I want. So if, that's how we check, if dog breed is equal to dog breed I want, colon, print they have the dog I want. They have the dog I want. Is that going to work? No. No. Inside your for loop, after you print each dog breed. So we still want a line where we say print dog breed. Damn it. So it says indentation error. Expected an indented block after the if state. Ah. Is that it? Wow, okay. Oh, and make sure it's they have the dog I want with an exclamation mark. And now we've got a tick. Okay. So by the way, the dog breed that you do want is a Dalmatian. So what we have printed out is French Bulldog, Dalmatian, they have the dog I want, Shih Tzu, Poodle, Collie, and they're the last three. Shih Tzu, Poodle, Collie. See, Shih Tzu, Poodle, Collie. So you'll notice how it does actually print all the 5 original members. So it doesn't go, oh, we found Dalmatian, so I'm not going to actually print Dalmatian, I'm just going to print they have the dog I want. No, we do in fact print every dog, and you might think, well, that's expected because we've got this line which says print dog breed, and dog breed is just a temporary variable for all the elements. But on the other hand, it doesn't print all 5 dog breeds and then go over to the task of saying they have the dog I want. Because if it did that, we'd have Poodle, Collie, and then they have the dog I want. So it's actually as if it prints they have the dog I want because it's just found Dalmatian. So it prints that right after it's found Dalmatian. And so that is a bit strange, I think. And that is what might cause you to think that we don't actually print Dalmatian. I can't really explain this behaviour by looking at these statements. If I looked at these statements, I might think that it prints every dog breed, every element, and then it gets to work on this line. It says, well, if the dog breed is Dalmatian, dog breed I want, then I'm going to print they have the dog I want. So presumably in terms of how it works, how the interpreter works, it kind of it looks at all. No. Right, so that's a good point. Dog breed only ever represents one value at one time. It's just that it changes with time, right? It's a temporary variable, tempo, time. Every time it is on one variable, so it'll be on French Bulldog first, for example, we do go through every line. So we don't go print dog breed and then do that for all print up, and then move on to this line. No, we don't complete this line and then move on to this line. What governs everything supremely is the value at that one time. So we say right, it's going to be French Bulldog for this point in time. Print just French Bulldog and then check, is French Bulldog equal to that? If it's not, just don't do anything. Don't print anything apart from, you've already printed the French Bulldog. Now we move on to Dalmatian. So for that, we'll do all the lines. Print Dalmatian. Is that equal to the dog breed I want? Or does it have the same value as dog breed I want? Oh, it does. So print they have the dog breed I want as well. So we actually get Dalmatian and they have the dog I want. So when you look at this output, what you should be thinking is, here, this line is French Bulldog, and potentially they have the dog I want, but we didn't fulfill the condition of being a Dalmatian. Then this is Dalmatian, and they have the dog I want, and they did fulfill it. This is Shih Tzu, and they have the dog I want, but we don't fulfill the if statement there. So we don't print that. But the point is, for each of these lines, there really is the potential for printing they have the dog I want, because for each value of the temporary variable, we do all the lines. They are given proper consideration for being equal to dog breed I want. It's just that they don't happen to be equal to it. Three, add a break statement when your loop has found dog breed I want, so that the rest of the list does not need to be checked once we have found our breed. So do I just write break here after the if statement? So if it really does work that way, so I'm making sure that break is in line with if, that's a really powerful word then, isn't it? Because it means we're going to halt everything. Break. It doesn't just sort of apply within the Dalmatian iteration. We don't go break and then the loop goes, yeah, break. Your time's up now. Now we move on to Shih Tzu. No, really. That's like a sort of safety word. No, break. We don't even get to print Shih Tzu or Poodle or Collie. So let's try. Oh no. Expected to see the output, French Bulldog, Dalmatian. They have the dog I want. So what's gone wrong here? Let's read the solution. So I put it at the same level as if. It looks like it's... we got it right, it's just that break needs to be more indented. I'm going to keep my code. So let's... oh, go on then. Run. Okay, so that works. Why? So the selected code is a for loop that iterates over each dog breed in the list. In the list, dog breeds available for adoption. For each breed, it prints the breed's name. If the breed matches dog breed I want, it prints a special message. They have the dog I want. But break is not indented properly. Why should break be at the same level of indentation as the print function? The break statement should be indented to align with the if statements block, not the for loop. Well, it is with the if. This ensures that the loop stops only when the condition is true. If break's at the same level as the print function, it will exit the loop after the first iteration, regardless of whether the desired breed is found. Here's the correct indentation. Break at the same level as print. Yes. But it says if break is at the same level as the print function, it will exit the loop after the first iteration, regardless of whether the desired breed is found. Well, I don't think that's true. Oh, it's talking this print function. Oh, I was looking at thinking of this print function. Right. So if that's what's problematic, break being at the same level as this print function. So what I'm saying is, yeah. If you do it like this, run. We're only getting French Bulldog because it's like this line gets a fair hearing, this line gets a fair hearing, and this line gets a fair hearing. It prints dog breed, right? So let's focus on Dalmatian. It prints Dalmatian. Is Dalmatian equal to the dog I want? Sorry, French Bulldog. So it prints French Bulldog. Is French Bulldog the dog I want? No. Okay, swiftly moving on. Break. Oh, okay, break. And we stop at French Bulldog, and that's what's happening. So when I indent this line, now there are only two lines that get a fair hearing. So we go through and we say, okay, the first value is French Bulldog. We're going to print French Bulldog. Is French Bulldog equal to the dog breed I want? No. Okay. And that's it. There are no other lines. We don't. That's not it. They're not at the same level. They're hidden away within this. And that's what we want. We want break to be hidden away. We want break to only get a fair hearing if we have actually printed they want the dog I want. So the way we do that is to put it sort of at the same level as this print. And of course it will only print this line if this is satisfied. And so it will only get to break if this is satisfied. If the dog breed is dog breed I want, if dog breed is Dalmatian. Okay, let's end it there.